Okay, so when you measure this, how long is this side on this triangle? It's about 5.6 actually. Okay, it's about 5.6. All right, how long is this side?
That's 8.
Yeah, it's like, yeah, it's between 7.9 and 8. We'll just go with 8. So that's 8 centimeters. How long is this side over here?
8.
It's the same thing. A little bit less than 8, but we'll go ahead and say 8. Okay, so what type of triangle is this? Oh, you're right. It is a cube. We'll get to that in a second. But based off of what we can see right here, it's isosceles, right? Because it's got two sides that are the same length. This side and this side are the same length. Now what I want to do is measure those angles as it said. So this angle right here is what? Yeah, it's a little bit less than 70, but we're going to go ahead and say that it's 70. I mean, it's just like half a degree less than 70. And so this one, same thing. It's going to be about 70. And then that means this one up here is what?
43. Oh, 40 or something.
Yeah, kind of having to split stuff here, but it's going to be 40. Okay, so it's isosceles because two sides are the same length. Now, if we base it on angles, what is it? Okay, it's a cube because all the angles are less than 90, right? But what I want you to notice is it's isosceles. These two sides are the same length. What do you notice about these two angles down here? They're the same, okay? And that's not by chance. It's not by coincidence. On isosceles triangle, you have two sides that are the same length, and you're going to have two angles that are going to be the same also, okay? That's just, that's what the isosceles triangle theorem says, and we'll look at in just a second, okay? All right, on this one, how long is this side on this smallest one here? 3.6. Oops. How long is this side? Same thing, 3.6. And then this side over here is the same thing. It's 3.6. Bless you. So what kind of triangle is this one? All the sides are the same length, so what is it? Good, it is equilateral. It's an equilateral triangle. Now let's measure these angles real quick. So how big is this angle right here? 60 degrees. How big is this angle over here? 60 degrees. How big is this one up here? 60 degrees. Okay, we talked about this like actually at the very beginning of this unit. But in an equilateral triangle, all the sides are the same length, but what else happens to all the angles? They add up to 180. And what else do you notice about all these angles? They're the same, and what are they? They're all, what number? 60. And I mean, if you just think about it, that's common sense. They would have to be 60. If they have to add up to 180, and they all have to be the same, then they're going to have to be 60, because 60 plus 60 plus 60 is 180. Okay? So it has to be that way. It's fixed. It's got to be 60, 60, and 60. So this is equilateral. And again, it's been a couple weeks since we talked about this, but they're also equiangular because all the angles are the same, and they're always going to be 60 in that. Okay? All right, on this one, how long is this side? About 6.2, 6.3. I'm going to say 6.2. Okay, and if you measure these, you're going to see they're all the same thing. They're all 6.2. All right. How big is this angle right here? 60. And again, if you measure them, they're all going to be 60. In an equilateral triangle, this is what it's always going to be. The three sides are going to be the same length. The three angles are always going to be 60. Okay, so that's good enough on that. Go ahead and look at our notes page here. Oh, my bad. All right. So really we just have this one last little thing to pick up for today. And really we've talked about a lot of this. There's a few little things in here I want to catch. But we're basically finished with this part of the unit. So doing this a little bit today. Tomorrow we will do our review for the unit. And then on Wednesday, you can see over there on the board, you'll be taking your tests on this stuff. So just to let you know. All right, so what this says right here, this isosceles triangle theorem says if two sides of a triangle are congruent, then the angles opposite those sides are congruent. All right. So you can see these two sides are the same length. All right, what I want you to do to write this down is that on an isosceles triangle, we call that side the base, and then we call these two sides the legs. All right, then the converse, we've talked about converse, it means to switch. But it says if the two angles of a triangle are congruent, then the sides opposite those angles are congruent. You can see that's exactly flipped from the hypothesis and conclusion from the original thing there. Okay, but these two things right here, this is called a base angle, and this is called a base angle. And this angle right here is what we call the vertex angle. Oops, sorry. Okay. So on this one it says find angle E in triangle DEF. Well, what type of triangle is this right here? What type of triangle is this triangle? Yep, isosceles, two sides of the same length. So since those two sides are the same length, what do I know about these two angles right here? They're congruent. It's just like what we just did on our warm-up. When those two sides are the same, then those two angles are going to be the same. Those two base angles are going to be equal to each other. So to find the value of x, I'm just going to set those two things equal. We're going to put 5x equals 3x plus 14. That's the relationship. They're congruent to each other. So we're going to set them equal to each other so I can find what the value of x is. All right, so subtract 3x from both sides. That way this zeroes out. That leaves 2x equal to 14. Divide both sides by 2.
7.
So x equals 7. And I need to know what x is, but that's not what it's asking for. It's asking for me to find the measurement of angle E. So I need to take that 7, plug it in right there. So 3 times 7 plus 14 is what?
35.
35. Yep. Which, I mean, over here you can see 5 times 7 is 35, which that's what we said, they've got to be the same. Okay, so this number one here, it says find the measurement of this, so angle C. All right, what type of triangle is this? It's isosceles. So what do I know about angle A and angle C? That they're going to be congruent. So what I want to do is I want to find the measurement of angle C. So what do you think we're going to do here to find the measurement of angle C?
Find the measurement of A, 180 divided by 180.
Okay, so I'm going to do 180 minus 78. That's that vertex angle up there, angle B. So 180 minus 78 is what?
102.
Is 102. Now that's 102 degrees to split between A and C. Okay? So 102 degrees is what I have left to split between A and C. But what do I know about A and C? They're the same, right? So they're going to be the same. So how am I going to find the measurement of angle C? Yeah, just take the 102, divide it by 2, and what do you get?
51.
You get 51 degrees.
Same thing on the other side.
Yep. Same thing on number 2. Okay, I'm looking for angle Q. And again, this is an isosceles triangle. So what am I going to do here? So we've done it that way. Let me show you another way to do this, okay? So I don't know how big angle P is, so I'm just going to say it's x degrees. So if P is x, how big is angle Q?
X.
It's x also, right? They got to be equal. So if you think about it like this, I could go x plus 86 equals 180.
Just 2x.
Right? So that makes 2x plus 86 equals 180.
Subtract 86 from 180.
Subtract 86. 2x equals 94 divided by 2. And what does that give you?
47.
It's 47. Which what I did here in algebra is the exact same thing that we did on number 1. It's just, it's been more systematic about it. It's doing it more algebraic. But exact same math on number 1 is what I did there. Okay, on number 3. So this is our isosceles triangle. So what do I know about these two angles right here? They're congruent. So I'm going to set them equal to each other to find the value of x. So I'm going to have 8x equals 6x plus 18. Subtract 6x from both sides. We get 2x equals 18. X equals 9, and then we want to find the measurement of angle H, so I'm going to plug in 9. 8 times 9, 72. Okay, number 4, same thing. Isosceles triangle, these two base angles are going to be congruent to each other, so I'm just going to set 2x equal to x plus 30. Subtract x. This one's easy. It already gets you right there. X equals 30. So if x equals 30, I plug that back in. 30 plus 30 is what?
60.
60. Okay, on the back. So again, this is following up on what we just did on our warm-up. In an equilateral triangle, the angles are always what?
The same.
They're always the same, they're always congruent, and specifically, what are they? They're always 60 degrees. It's always going to be like that. So it's got to be. They have to be the same, and they have to add up to 180. They've got to be 60. So on this one right here, all three sides are the same length. So it's equilateral, which means all the angles are equal. It's equiangular. So what I'm going to do here is just set 7x plus 4 equal to 60. All right, subtract 4 from both sides. So we get 7x equals 56 divided by 7. And so x equals 8. Okay, so on this next one, all right, so it's equilateral, which means it's equiangular, which means all the angles are 60 degrees. So to find the value of n, I'm just going to put 5n equal to 60. Divide by 5, and n equals 12. Okay, number 6, same thing. It's equilateral, which means it's equiangular. So all the angles are 60. So I'm going to set 2x minus 6 equal to 60. What does x equal? Okay, so on this first one, on number 5, it shows that all the sides are the same length. So that means it's equilateral. On this one, with this marked, what does that mean? It's equiangular. All the angles are the same. But remember, those two things are mutually inclusive. If it's equiangular, it's equilateral. Okay, and if it's equilateral, it's equiangular. So it goes both ways. All right, so it's like this. If all the angles are the same, then we know that all the sides are the same. All right, so here to find the value of r, I know these two sides are the same length. So I'm going to set 9r equal to 5r plus 8. And then just solve for r. So 4r equals 8 divided by 4, which means r equals 2. And if r equals 2, how long is VT? 5 times 2 plus 8 is what?
18.
Is 18. Okay, then on this last one, same thing. It's equiangular, which means it's equilateral. So to find the value of y, I know that ML is congruent to MN. Those two are the same length. So y plus 10 equals 4y plus 1. Get the y's together. 0 out, 10 equals 3y plus 1. Take away 1 from both sides. This zeroes out. 9 equals 3y. Divide by 3. So y equals 3, and then mn, I'm going to plug in that 3 here, so I'm going to go 4 times 3 plus 1, which is what?
13.
13.